Yes, I can hear you.
And we can hear you as well.
All right.
Can she write and hold it up on the screen?
For we have the report actually has a map that's only from 2013, and you'll see why in the next slide. So it looks a little different, but similar. The dark dots have low concentrations, and what's interesting here is you do see kind of this hotter spot around the city of Greenfield, and then a little bit kind of up west of Soledad. And I don't have an explanation for that. I mean, the nitrate's going to be coming from fertilizers almost entirely, and it's possible that there's just been a slightly longer history of agriculture going on close to the town. I don't know, but that pattern of water quality issues right close into the city is common to a number of constituents.
Gus, can I pause you just for a second?
Yeah.
So I just want to note for the record that Brian Mendoza has joined us. We have 5 members of the committee, so we now actually have a quorum.
Okay.
At the end of your presentation on this item, we'll go back and take care of the administrative things. So go ahead and proceed.
Okay. The time history of nitrate is kind of interesting. This is the only one where there might be an increase that's visible and real. You can see that after about 2005, high values were much more common. We don't know whether there might have been a change in monitoring effort, which could easily do that. People are looking for wells with high nitrate, for example. But it's also possible that this is a real increase in nitrate concentration because it's been demonstrated that the lag time between when a fertilizer leaches below the root zone and the time it shows up in a deeper aquifer in the Salinas Valley is like on the order of 50 years. So that there is actually a delay, and so it's possible that we're seeing the delayed arrival of fertilizers that were applied in the 1950s and 60s. Um, so it's hard to say, but the higher values are more recent, and so the updated map and the report is actually for data since 2013 to paint a more current picture of where the high values are. It looks a lot like the one I just showed you. This is 123 TCP. It's gotten attention in recent years. It's a breakdown product of a pesticide that was banned a long time ago, but they finally made an MCL for it in 2017 that's very low. It's at 5 parts per trillion. And then in the last couple of years, they've sampled about 200 wells in the area. These dots on the map are the 30 or so wells where it was detected. But the MCL is so close to the detection limit that almost all of the detections were in fact above the MCL, meaning it's a primary health violation. And hate to say it, but they're all right there in the Arroyo Seco management area. So I don't know what the source was. The highest point by quite a bit is this hot red dot that's way up on the Arroyo Seco cone. It almost looks like there's a plume going down, but it's hard to say. But it is a primary health issue, and it's right here in the Arroyo Seco management area. Let's see. Here's a chloride just to show a similar another pattern that's common to like specific inductants and TDS is you see this big patch of green dots over here on the left. Those are the low values, and a number of constituents show the effect of dilute recharge from the Arroyo Seco, and that water moves northwest. And so it makes this band of nicer water quality up against the western foothills. And then as you go east, you get more into the Salinas River signature. And once again, you see kind of a lot of orange and red coloring right around the city of Greenfield for whatever reason. But that was a common pattern. Here, chloride concentrations, you can see the problem with variable monitoring intensities over the years. These data, we got data from a lot of different databases, and these water quality has been monitored for different reasons. over the decades by different agencies under different programs. So it's not a really systematic long-term picture. We don't know if it's, we didn't go back to see if, is this the same wells and are the distributions the same, where they're located the same. So there's a definitely, this whole analysis would help from a more systematic monitoring program for water quality. But this is just an illustration of why that's so. So conclusions are the problematic constituents are chloride, hardness, nitrate, sulfate, TDS, and 1,2,3-TCP, all of which commonly exceed MCLs. Nitrate was the only constituent with an apparent increasing trend. And rural wells are distributed throughout this study area with little clustering. So what does that lead to? One of the approaches to rural water quality would be to connect people to a municipal distribution system. And pipelines are really expensive. So it's hard to do that for a lot of scattered homes out in the, out in the boonies. But you can see that kind of halo of poor water quality around the city of Greenfield. There's also a fair number of those blue dots and a fair number of domestic wells in that area. So that's one region where it might make sense to tie people into the city distribution system. I don't know anything about the, the LAFCO issues and all of that related to that issue, but in terms of cost-effective solutions to this domestic water quality problem, that's one area where connecting to a existing central system could make sense. Otherwise, your options are point of use or point of entry treatment systems. Reverse osmosis in particular strips out just about everything. So it would handle all of these water quality problems. And they have relatively inexpensive under-counter units that can supply one tap, and you use that one for drinking water. If you want whole house treatment, so you get softer water, for example, you can do a point of entry system, either softening or reverse osmosis. And then finally, the final conclusion, just to reiterate, is a more systematic long-term monitoring program for water quality would improve the ability to analyze these patterns and trends. So that's the summary of the rural water quality report. I'm happy to take any questions.
So I guess before we get into, well, we can certainly stop, but I was just going to frame a couple of issues. You guys will recall when we were putting together the original groundwater sustainability plan for the Rio Seco, this idea of consolidate. I think it's on. Guys, can you hear me?
Yep.
Okay.
We can hear you much better, Curtis, when you're speaking more directly into your microphone. It's a big difference.
That'll be hard for me because I can't talk with my hands, but I'll do my
I
best.
understand.
Like I was saying, you recall that as we developed that GSP for the Arroyo Seco, before we developed the Arroyo Seco management area, we were looking at consolidation as one of the ways to deal with water quality issues in rural urban connections. So that's, Gus said that it got rolled into the 4-bay GSP, and I just wanted us to recall that that was the path, the way we kind of organically got caught. And it was good that we captured it, and we were able to get grant funding to do this initial work. This is just a preliminary kind of what's out there. Gus's recommendations or conclusions are pretty straightforward and not surprising. I will say that when we look at actually trying to connect some of those rural water users to the city's domestic supply, there's a whole host of issues that we'll have to get over. They're not insurmountable, but they're not easy either.
They've already done some of that.
Yeah. And some of it's not been very successful in the eyes of the city. I'll just say it that way.
Yeah.
So I'm just saying it's certainly a way to make water available to rural customers of higher quality. Gus also mentioned, under the sink RO units, great idea. I mean, I have one myself in my home because I've got, a groundwater well. It's got really high sulfates. So, there's a couple of different ways that we can move forward. The point is that we wanted to do kind of an inventory. If you notice, Gus didn't take just the Aroma Cycle management area. He didn't take just the forebay when we kind of expanded it. So we got to build a little bit better look at some of the southern footprints that we have. So any other questions or comments?
So after, what, 14, 15, 16, or whatever it was, it looks like a lot of those numbers come back down. Or they just, you haven't gone out far enough yet.
No, I looked at whether some of the high values appeared to be associated with low groundwater levels, because that can happen when you lower the water level in an aquifer. It depressurizes the intervening clay layers, and the water in the clays often has poorer quality, and it starts sort of oozing out into your aquifer. But in most of these where you started seeing some high values in the 2010s, they were starting around 2012, 13, kind of before the water levels got really low. So it didn't look like that was what was happening to me. That's mentioned here and there in the report.
Roger, go ahead and grab a mic and.
Sure. That line of TCP, what, I don't rec, what chemical is that?
That's man-made chemical used for a variety of purposes, including solvent, pesticides, and paint removal.
We used to use it for fumigating for carrots.
I don't think I ever grew carrots.
Well, probably then for chilies.
So it's a pesticide residual.
Carrot?
No,
Trichloropropaine.
it was a fumigant.
Oh, okay.
Yeah, anyway, you remember the stuff they took out of the transformers? That was 123 TCP, right?
No, the PCB.
Those are PCBs, yeah.
Oh,
Yeah.
I'm not sure then.
This is a little bit alphabet soup here.
Yeah.
But in any case, so I think one
Well,
of the other-
you look at it coming right down the river.
yeah.
Yeah,
One of the
there's a
other-
county dump right there on top of the river.
Was it? Well, like I said,
Paint, yeah.
this is just an initial study.
It's just this.
Clearly,
It goes right down the river and you're thinking, now how were we fumigating the river bottom? I don't think so. But there is a little county dump and there's this real bright red spot that he pointed out right where the dump is.
Oh, is that right? I had no idea. I said it kind of looks like maybe this is a plume, but just from that one figure I showed you, which is
So some poor soul has a domestic well right next to the old unregulated dump.
Down the river from it, a bunch of them.
so I guess that'll be something for us to note and to
yeah.
follow up on. But you also notice that the water quality did improve down the Arroyo River as it went towards the Salinas compared to some of the other, I think that was chloride concentrations. Was
We've
most
always
pronounced?
known that. Saline water versus Arroyo Seco, that's,
Well, but you can see it.
Yeah,
It's-
but-
it's-
Let's see.
I know, we all know,
Um,
but it's,
no surprises.
no surprises.
Yeah.
You put a camera in those wells over here and all the water, you can watch the water run through it, and then over here it's sort of stagnant.
Yeah. Well, okay, so here's my takeaway. I wasn't surprised by anything in the report. It's pretty much what we anticipated, but it's a nice place to start. So now we kind of have, arms around a little bit better data, a little bit better format, especially when we look at some of the data around the cities, and we know that there are some water quality issues in rural wells that are close to potential consolidation sources. So those are all good things for us in terms of managing in the future, provided we can work out the institutional things about bringing them in an equitable way and making sure the county and the cities essentially cooperate with one another.
Gus, this was a study of rural domestic wells, and you have the big blocks around the municipal delivery system. So I guess you probably didn't look at the source wells of the municipal distribution, but I wonder if they had similar constituents as what you're.
We didn't specifically. I I think those, Ed might have stripped those out. Typically what you find is that the water quality from municipals is fine because it has to be. If there's a well that doesn't meet drinking water standards, they can't use it. So it's
Well,
not
right,
very
after
risky.
it's treated, but I'm just curious about the source wells.
No, I don't know that anybody's treating, is anybody treating for TDS or chloride or sulfate in their municipal wells? I mean, they would treat for disinfection, but is there other municipal treatment that happens around here?
Not that I'm aware of, but
Yeah.
most domestic wells for the cities they're disinfected. That's about it.
Yeah,
Yeah.
that's what I would guess. So the mineral concentrations would all be below MCLs because they have to be. Yeah.
Now, they may be deeper,
Yeah, they might be.
and they may be in areas where water quality is better. But I think Gus's point is a really good one. They're regulated, and they have to be drinking water.
Right, yeah, I just assumed it was because they were treating it somehow.
Sure, understood.
I think so. Yeah, we could do additional analysis stratifying some of the water quality data by, well depth and type. There's more you could do, but I'm not, yeah,
But that wasn't where we were headed. Well, that wasn't.
yeah, that wasn't, I'm not sure it would
We
take
weren't.
it any different conclusions or plan of action, frankly.
Do some of the constituents like rise to the top of the water table?
No, if these were shallow wells and it was a gas station leaking sort of thing, then some hydrocarbons are denser than water and some are lighter, and you do that because you get that sort of effect. But these are all very soluble things that just pretty much move with the water, so you wouldn't they wouldn't separate out in an aquifer by floating or sinking.
Gus, the chloride concentrations on some of the wells, I'm not, you tell me. In the lower part of the watershed, they have saltwater intrusion issues, and it's something we're supposed to be aware of as one of the important factors on groundwater management. Because we have higher concentrations of chloride here, comment to me about what that means with the expression saltwater intrusion.
Yeah. Well, the chloride and TDS concentrations here don't have anything to do with intrusion up at the coast. What they mostly reflect are the influences of marine formations that are predominantly on the east side of the valley, like the Pancho Rico Formation, which is on the east side of the valley and underneath the valley up in the upper valley of subbasin. It's a marine formation with pretty icky water quality. It's fairly saline, and so when you see high salinity values in this area, some of that could be leakage coming out of the Pancho Rico Formation. And here in an agricultural area like this, you get quite a bit of evaporative concentration of salts when you irrigate, and eventually that's going to, raise your overall TDS levels. Not like saltwater intrusion right at the coast, but you would expect to see a long-term gradual increase in chloride and TDS just from evaporation of irrigation water.
Thank you. I believe that, it all makes sense to me, but from a layperson standpoint, sitting in the advisory committee, I'm happy to hear that there's, and we've heard that there's not a saltwater intrusion issue here. And even if we had a sentence saying that this is distinguished from saltwater intrusion, that's like a check the box for me.
Oh, I see. Okay. I guess we could do that, sure.
Yeah, I like that idea.
Okay.
Any other questions or comments? Any comments or questions from those online?
This is Jerry Laura. I'm glad to listen here. And we, of course, have our winery there. And I'm embarrassed that I don't know just what our current water treatment for the winery is. So, Gus, or for the group, I could get back to you when we find out. And I read this carefully. And I'm, concerned there. But I'll get back to the group with what we're doing.
Thank you, Jerry. Any other comments? Okay, so now that we have a quorum, with the addition of Tim's request to add a note that the chlorides and sulfates, chlorides in particular, don't indicate any seawater intrusion in the area, are you ready to move this to the board of directors? So your action today was this is the one action item that we have. And staff is asking you guys approve or recommend that the board of directors approve this study.
So do we need a motion?
Yes.
I have one more question.
Sure.
Some of the constituents, now that we're learning like chloride, you think, if I'm hearing it, is a naturally produced constituents from old marine deposits, for example. So some of these are natural baseline conditions based on mineral, and some are a combination of man-made stuff and natural, and some are specific to man-made. Is that a good characterization?
Yeah, mostly it's one or the other. So let's see, looking at the list, the specific conductance, sulfate, total dissolved solids, hardness, iron, fluoride, chromium chloride, boron, probably arsenic, and certainly alkalinity are all just naturally occurring things. There are some, wood treatment processes for which they use arsenic, but I wouldn't expect there to be a large sort of human source of arsenic. Nitrate, on the other hand, is going to be almost entirely of human source, and certainly all the 1,2,3 TCP and hydrocarbons. Those would not occur in nature.
So again, from a layperson standpoint, that's useful information.
Okay.
And I bet if we elevate that, that would be useful to the board also.
Okay. Yeah, I can add that. I didn't think of that.
Good. It's good to be a dumbass, dumb layperson.
Those are good questions.
So that was, we'd already approved it and it's all by now.
I gotta make it 2 o'clock, so I'm gonna sneak out of here, so just telling you.
Would anyone make a motion to recommend the board of directors approve the study?
I'll make the motion with the additions of,
Mr. Fromm's comments.
I'll second it.
Because we are on a combined Zoom and in-person meeting, we need to do a roll call. So you want me to do that, Ian?
Either way, I have everyone's name now. Alan Pantera,
Aye.
Michael Riva,
aye.
Mary Lerner,
Yes.
Roger Matoso,
Aye.
Tim Fromm.
All right.
That's, thank you, men and women.
All right, Laura is also here.
Oh,
Good night.
But Jerry, you and Nancy you're participating as members of the public.
Okay.
Members today.
Okay.
If you were here,
Thank you.
and if in the future, if we're going to do you remote, we need to notice you on the agenda. That's something we'll follow up with after.
Fine. Thank you.
You bet. Okay, Gus. Let's go move on to our next item. Oh, wait. Time out. Okay, so the meeting officially started at about 1:11. That's when Roger showed up. We were in the middle of going through item 3, I think, on the agenda. We've essentially called the meeting to order. At this point, I'll entertain any kind of public comment, just to be able to check that box, to make sure that we've got it covered. So is there any public comment? Okay, I'm not seeing any raised hands. I thank you for that. We'll move on and continue, Gus, on our next item.
Okay, next item is sort of an update on what we're doing in the Sustainable Management Criteria Technical Advisory Committee. It's a joint 4 Bay Upper Valley Committee. And I will show you another show. I have 3 shows here. Um, so this committee got underway earlier this year. There are 4 members, me, Dwight Smith, Bob Abrams, and Jim Strandberg. And we've met 3 times, the most recent time in November 20th. And our assignment is to translate the sort of measurable objectives and minimum thresholds in the GSPs into more specifics and a procedure for evaluating data from each year's annual report with respect to those criteria. So there's actually a lot of detail. It's not as trivial a step as you might think. And so we've been chewing on it. And ultimately, we plan to have detailed evaluation procedures for the 5 sustainable management criteria that apply in our area. Seawater intrusion's the one that doesn't. But so far we've tackled only one, which is water levels. It's also probably the most important and most difficult one, so that's okay. And we're about to proceed to storage and subsidence, and then eventually we'll get to water quality and interconnected surface water. So this, when they set up this SMC TAC, it's kind of a slow motion process because they originally thought it would just be meeting once a year in April to look at the annual report. But we have a lot of groundwork to lay here. So I'm the chair of the group and I've pushed to have some extra meetings. So we've had 3 this year, but I don't think Montgomery and Associates, who provide some of the materials for each meeting, expected to be doing this that much. But we're making good progress. So I'm going to describe what our current proposal for evaluating water levels each year with respect to the sustainable management criteria. And I'm just going to show you what we came up with. Each piece of this was a subject of quite a bit of discussion and comparison with data and alternative ideas. So we can get into that if you want, but I'm just going to tell you where we wound up. And you can see if it makes sense to you. So we recognize that there are kind of 2 types of water level issues. There's the short-term declines that happen during droughts when they stop making those conservation releases for 2 or 3 years in a row, and that's what happened in 2014 to 16. Big drop in water levels, but they mostly bounce back up once the releases come back. But you can also have sort of gradual long-term declines in water levels just due to changes in the groundwater budget. This is more what DWR was envisioning when they created Sigma. And back in 2018, when we were starting our GSP process, it didn't seem like we had that problem very much, but that picture is changing. And so we actually do kind of have that problem, and we need a way to evaluate it. So here's the procedure. So the annual reports are due each year at the end of March. And so it's envisioned that our technical advisory committee would meet in April to look at the data from the previous year. The data would only go through October of the previous year, so there's a 6-month delay between the end of the water year and when we get the report. And we decided if there's a DTAC that's active, so the DTAC is the Drought Technical Advisory Committee. It gets activated if reservoir storage in October falls below a certain level. And it starts making plans for reservoir releases the following year. If reservoir storage recovers during the winter because it happens to be wet, then they disband and nothing happens. But if it gets to be the end of March and they're still active, that means we have a very dry situation. So if a DTAC is active, and so that relates to sort of the reservoir part of this picture. Or if 30% of the representative monitoring site wells, that's what that stands for, if 30% of them have water levels that are, dropping below the measurable objective, and we picked a level that's 75% of the way going up from the minimum threshold to the measurable objective, and that's to give us some a running start if things are starting to go down, basically. If 30% of the wells have water levels that are less than that, um, then we start doing some more analysis. First thing is check the alternative RMS wells for a similar pattern. So these RMS wells are just a subset of all the wells that get monitored. Um, somebody else picked them. There's a fair number of RMS wells, but there's all these other wells. And so we thought, well, the first thing you want to do is get the whole picture. So we bring in the other wells and see if they all show the same pattern. And with that number of data points, you can have a much better idea of, is this a widespread pattern or is it a clustered pattern? We decided to leave the definition of clustering subjective. It would be evaluated somewhat on a well by well basis because there's different reasons a well might have a low water level, and we played around with sort of objective criteria for defining a well cluster, and it was too clunky. So we thought that's one that's reasonable to leave to hydrogeologic judgment. We've checked the alternative wells. We've looked for is this pattern everywhere? Is it just local? And if the pattern is real, then we recommend a management action to be implemented by the following year. So by April, the growers have picked what they're going to be growing, this year. So there's not, and a lot of water projects take many years to implement. So the only thing you can do quickly is like demand management. And if the farmers have, already planted or got their crop plans lined up for this current year, then you're not going to be able to do a lot this year. So you look ahead to next year, in case you get another dry year. So that's why I said we wanted to get a little bit of a running start on this. So one of the things we would then do is say, let the growers know what's the probability of 1 or 2 additional years of low reservoir releases, and what would be the additional water level declines that would result. That was a suggestion that came from one of the, public members participating in the meetings. It's like, yeah, the growers know what to do. We just need the information. And so certainly that's something we could provide is, yeah, we got our first dry year. Here's the probability of a second one and how low we think water levels would be if that happens. And then the growers can decide if that's going to change their planting plan for the next year. And if we think if the problem is chronic enough, then, for example, it's a long-term decline issue, then we might recommend starting planning and design studies for some type of wet water project that would change the local groundwater budget through additional recharge or whatever we come up with. So that's the plan for dealing with short-term declines and long-term declines. Then, well, that was the short-term declines. Sorry, here's the long-term declines.
That's going to interrupt.
Yeah, sure.
Tim's got a question on the short term.
Oh, sorry. Go ahead.
I think it's on, could you bounce it back the slide?
Yeah.
So wet water projects could take 10 years to bring online. Is that because it's going to take 10 years to envision them and set up infrastructure?
Basically, yeah, you have to figure out what's going to work, and that's not necessarily obvious. It can be hard in this valley to find a place to park water where it won't get away from you if you're trying to store it for many years. And then you have to do the design work and environmental permitting and, line up funding, and then you got to build it. And it's not uncommon for a water project to take that kind of time. By that time, the current drought will be over, right? So it's not something you can do in a hurry. You could potentially implement some emergency field flooding, but that's something you do in a wet year. You'd need to have that planned ahead so it would be ready to trigger in a wet year. Any of those things might take a couple of years to get ready. And so I guess it would be up to our committee to recommend which, where and which type of project to start designing and implementing for a wet water project.
Got it. So wet water projects are projects that you implement when it's a wet year. Anticipate.
Well, rather than demand reduction, which is just you pump less. Wet water means you're actually moving water around and trying to get it in the ground and store it, and that's what I mean by wet water.
Right. Well, if you're moving water, let's say on a good year or a wet year,
Right.
to recharge the groundwater to increase the
Right.
elevation.
Right.
So do you have the data showing how much recharge you get in just in a normal wet year of running water down the river?
Well, the hydrographs sort of answer that question. You see a lot of recovery in a wet year. The Salinas River is a pretty good, and the Arroyo Seco, of course, are big sources of recharge for this area, and the groundwater levels do respond quickly to water coming down those two rivers.
So that's a wet water project that is implemented immediately.
Well, right. It's sort of our existing condition in a way. It's just that we know that the reservoirs aren't 100% reliable, so you do get these short-term decline, these 2 to 3 year low water level periods that can be, you can lose some of your well yield. And the question is, well, are there other ways to bank water in the basin itself rather than in the reservoirs that could help carry you through some of those drought sequences?
Right. And then I think at some time in the past, we asked if there was an idea on what the sweet spot is. How much can the groundwater absorb? How many acre feet is the sweet spot releasing out of the reservoir to get the maximum amount of recharge?
Well, I don't. Yeah, I don't have a immediate answer for that. I've been thinking more in terms of if you're trying to add additional. So the rivers the river is a very effective recharge source.
Yeah.
Whether you would park more water in the basin rather than the reservoir is an interesting conjunctive use possibility. And it's one worth looking. So, for example, suppose you diverted some water from the river up in the Upper Valley area and percolated it up closer to the foothills. It would take a few years for that to try and percolate back to the river. You could store it for that period of time, and then evacuate some store capacity in the reservoirs to catch more surface runoff. That sort of conjunctive use has not been technically evaluated, but it's something that perhaps should be.
I can say though that the HCP process
Yeah.
is looking exactly at those kind
I know.
of conditions. That is, can we release more water, especially during winter months, to facilitate recharge that we haven't done before, and evacuate additional space in the reservoirs to be able to capture more during wet years. That's a give and take.
Yeah, the HCP is looking at it from a fish passage standpoint, but we're looking for additional ways to rationalize it to the.
Yeah. I think it's possible that my sense of the Salinas Valley is that it's not like a really huge basin, but it's also not like one of these narrow creek stream aquifer systems. It's kind of in between. In other words, the river has quite a strong influence, but it's not as if water levels always rebound to the same river level every year the way they do in those small stream aquifer systems. It's big enough to have its own storage, slightly independent of the river. So you have to plan something that fits that kind of system. But you do want to be able to have water that you can hang on to for at least 2 or 3 years to be of any value during a drought sequence.
But before the Salinas Valley Water Project, we had a different way of operating those reservoirs. Because they were essentially made to recharge water in the Salinas River all the way down to about the sprinkles. And at that point, the agency tried to control the end of flow so that all of it was going into the ground to the extent possible. So it's a different kind of operation. And I don't know that there's really been any specific analysis on the difference between groundwater elevations between those two types of operation. Although most of the modeling showed that when we're pushing more water to the river diversion, we're getting additional recharge. We just have more water to be able to actually percolate into the ground through the river system. That's what the modeling showed. Given the variability in year types and, it's a pretty complicated question.
Yeah, complicated question which may result in a simple solution.
I'm way in favor of simple.
Okay, shall I continue?
Sure.
Okay. So for those long-term gradual declines, the first thing you need to do is figure out what's an appropriate period of analysis. It needs to be long enough to see the trend separate from any shorter term droughts and wet periods. Typically, a 30-year period is commonly used as representative of a sort of hydrologic system in California. And we decided the best best way to pick a hydrologically representative period is the cumulative departure of Arroyo Seco annual discharge. That particular metric is used for other reasons like the fish releases. And it's a pretty good indication of when you're going through wet periods and dry periods. So you want a period where those discharges kind of equal the long-term average. And you also want a period that doesn't start or end in an exceptionally wet or dry condition. Otherwise, that tilts your regression slopes. And it can be tricky to meet all three of these, but that's what's desirable. And then you calculate the trend of the water levels for that period. And we played around with parametric statistics, which is just regular linear regression, and then non-parametric statistics, which would be the Mann-Kendall method. And the non-parametric method overcomes some problems of outliers having too much influence. So we recommended that. And so you get a slope based on that method, and you evaluate it statistically for significance and also look at it visually for bias. The reason I say visually for bias is the non-parametric method is sort of ranking numbers rather than taking their absolute values. And in California, you can have one wet year and a whole lot of dry years. And if you're just saying whether one's a plus and the others are all minuses, it won't balance out in terms of the number of minus years versus the number of plus years, even though there's a whole lot of water in that one plus year. So you do have to be careful inspecting your results. And then finally, you look at the hydrographs, the water level hydrographs for recovery following droughts. If a system's really stable, then you should get, full recovery in the wet periods following each drought. And if they aren't coming back up to kind of where they used to be, then that's a clue that you have a long-term imbalance. So what's our criterion? Well, if 35% of the RMS wells have a declining trend or declining post-drought recovery, then what do? Well, like with the short-term ones, we expand the analysis to include the alternative RMS wells and look for clustering of decline. So if you have a change in land use or a bunch of new wells in a small area, you can get a local change. Water levels can go down locally, but it's not representative of the whole subbasin. So you look for clusters. So if the trend appears real, then we want to know, well, what's causing this downward trend? Because if you don't understand what's causing it, you might not pick an appropriate way to deal with it. So our thinking is to look at other factors for which data are available that could relate to these long-term declines in water levels, including pumping, land use and crop types, reference ET, water levels in the downstream subbasins. I mean, is this just a cone of depression, slowly creeping up the valley from the low water levels near the coast? The number of well permits issued each year suddenly there's a whole bunch more wells, and any changes in reservoir operation. So we'd go through those to see if any of those have patterns that might correlate with a long-term decline in water levels. At that point, we kind of report back to the implementation committees what we found in terms of locations and magnitudes of long-term declines and what we think might be the possible causes of the declines. We would also be tasked with recommending management actions to start implementing, the following year to either, demand reduction or, water supply sorts of projects that might take a number of years to actually get up and running.
So Michael, I have a question on the previous slide.
Okay.
Yeah, I would, I guess my argument would be, that, E is of no consequence. I often say that if every farmer in Monterey County had twice the amount of wells that they have now, we would actually use less water. We wouldn't be trying to make one well run around the clock in the wind in non-optimum times. So I'm not really sure. I guess if I saw a well permit taken out with some ground that had never been in production before, that would be something that I could say could be a trend or a problem. But I don't know. To me, E doesn't. It doesn't correlate straight across for me.
Yeah, I mean, I see your point, and it's sort of indirect. If the acreage, irrigated acreage hasn't changed, then the number of wells doesn't really, supplying that acreage doesn't really, maybe not make a difference. We just thought it would potentially be an indication of some sort of increase in groundwater use. But theoretically, the pumping data set and the crop land use data sets would already have captured that. So yeah, I see your point.
Yeah, no big deal. Just something I caught my eye there.
While we're here,
Go ahead.
Gus, all of those are actions that people take, but what we don't see is if it's like a 30-year trend or 30-year look, is climate or, precipitation, I mean, that type of stuff, long period drought or are you starting to look at climate change, looking forward?
Yeah, I did include reference ET here. And for the 30-year, the analysis period is supposed to be representative in terms of surface runoff because that's how we picked it at the beginning. But if that whole climate system is changing, then, the 30-year period itself might be changing, is sort of what you're saying. Yeah, that's a valid, a good point. Oops,
Other questions or comments?
I'm gonna go.
So before we move on to the next item, I just want to note that the meeting was officially adjourned at 1:40. We lost Roger Matoso, one of the committee members. Doesn't stop us from having a discussion. We can still go to the next item, have a discussion, but no action will be taken.
Can you turn the recording off? Do you stay recording?
No, you can turn the recording off.